Question 1. Get the algebraic expressions in the following cases using variables, constants, and arithmetic operations from 1 to 8. This question is just a revisit of what we have learned in our previous standard. So we will do it straight away. Number first is subtraction of z from y. That is, first of all, we must have y from which we are going to subtract z. Therefore, first of all we had y, and from that we subtracted z. Therefore, y minus z. Second, 1/2 of the sum of numbers x and y. So and means addition. 1/2 of the sum. So first of all we'll have to consider this part. Sum of numbers x and y. It is simple. That is, we are adding variable x and y. So we did first of all x plus y, and whatever we get, we are going to half it because it says 1/2 of the sum. Therefore, equation becomes 1/2. Nothing means multiplication of x plus y. Third, the number z multiplied by itself. Well, it is very simple. We have a variable z and it is getting multiplied by z itself. Therefore, it can be written as z into z, or in short form z squared. It is read as z squared or z raised to power 2. Fourth, 1/4 of the product of numbers p and q. So initially we are having numbers p and q, of which we are going to have product. Product means multiplication. Therefore, p multiplied with q, or it can be straight away written as p and q, and we have to divide it by 4 because 1/4 means 1/4. Nothing means multiplication. Therefore, this is the required algebraic expression. That is 1/4 PQ. That's your fourth. Fifth, numbers x and y both squared and added. So we have two numbers or variables in this case, that is x and y. First, we need to square them. Both means we need to square them individually first of all. Therefore, answer will be x square and y square, but they are also added. Therefore, first we are going to square individually x square and y square, and the operator, this is called operator, that will come in between them is plus. Therefore, x square plus y square. Sixth, number 5 added to 3 times the product of numbers m and n. So first of all, we will not see added portion. We will consider this part. That is 3 times the product of numbers m and n. What is product of two numbers? It is simple multiplication, that is m n. Therefore, we write mn, but we have to take this thing 3 times. Therefore, we wrote 3 into m into n, and then we add 5 to it. That is 5 plus 3mn. This could also be written as 3mn plus 5. That's 6th. 7th, product of numbers y and z subtracted from 10. So initially we had 10 and we have to subtract product, that is multiplication of yz or zy. That doesn't matter. Therefore, 10 minus yz. It will not be yz minus 10. That will be wrong, because in subtraction we have to keep order in mind, because it is saying from 10. Therefore, 10 has to be taken first. Last part, sum of numbers a and b subtracted from their product. So from part will come first. Therefore, product means multiplication of what? A and b. Therefore, we wrote first a, b, and what we are doing, we are subtracting what? Sum, that is addition of a plus b from this. Therefore, minus, we write it in bracket because this is one term, because first we are adding them and we are subtracting this addition from product, that is ab. Therefore, ab minus bracket start a plus b bracket close. That's your last, and that is first. Second, first, identify the terms and their factors in the following expressions, and we have to show the terms and factors by tree diagrams. And second, identify terms and factors in the expressions given below. Prior solving this question, let's visit the concept. So, if we have this expression, then the individual terms which cannot be further broken up are called as factors. So, when we multiply 2 and 3, we get 6. So, these are factors. They cannot be further divided. And in terms of algebraic equation that consist of constants and variables, we have these things. So, these are called coefficients. That is mainly the numerical part that is associated with a variable. And what are variables? These are letters written in small alphabets. And this is constant that don't change its value. That is 9 will always have its value as 9, or any number for that matter. What are terms? Terms are individual expressions that contains factors and which are added in order to form an algebraic expression. So in this, 2x is a term, 4y is a term, and 9 is a term. They are getting added up. With this, let's start answering. So first one is x minus 3. Well, it is an expression. And what are terms? Terms are individual algebraic expressions that are added up. So here one is x and here one is minus 3. And we are representing factors with dotted lines just to differentiate. So what is a factor here? Only x we have, and here minus 3 is the factor. In case of minus, you have to take minus sign as well, because if we are eventually adding it up to form x minus 3, it can be written as x plus bracket starts minus 3. So plus minus will be minus. Therefore, rather than saying minus, we always say that we add up terms in order to form expression. That's A. Moving to B, we have 1 plus x squared. So it is an expression. And what are terms? Individual expressions that are added up. So here 1, it is getting added up to x, therefore x another term, and x squared is another term. So total we have 3 terms. And further, factors, here we have 1 as a factor, but in algebraic expression we omit 1, we don't write it, it is understood. Here we have x, and here x squared means we are taking x 2 times, therefore x and x are factors. That's B. C, y minus y cubed. So this is the expression, and terms are y and what here? Minus y cubed. Not only y cubed, it is minus y cubed, because when we add them, it will be y plus in bracket minus y cubed, and plus minus we give minus. Therefore, always remember to write negative sign to form a term. So here we have 3 factors, minus 1, and here we have 3 y's because it is y cubed. So y, y, y. That is your C. D. 5x y squared plus 7x squared y. So this is the expression. And terms, we can only see one addition, therefore this is one term, this is another term. Writing it here, 5x y squared, 7x squared into y. These are terms. And now writing its factors. Here we can see 5, x is 1 time, y is 2 time. So y. Now here 7, x is 2 times, therefore x, y is single time. So these are factors. That is D. Last part, minus ab plus 2b squared minus 3a squared. So we can see 1 term, 2nd term, 3rd term with minus sign. So here minus ab, here we have 2b square, we don't have to write plus, here minus 3a square. Now here minus 1, because if there is no coefficient written, it is understood it is 1. And for minus sign, we write it as minus 1. Here it is a, here it is b. So these are factors. That is smallest individual units who has their own existence. And 2, b is twice, so b, b. Here minus 3, a is squared, therefore a and a. So in this way, you find terms and factors of the given expression. That's second. Second part of second question, identify terms and factors in the expressions given below. So these are the expressions and we have to find terms and factors. So in this, first of all, make 3 columns. So these are columns and these are rows. First of all, writing expression as it is, minus 4x plus 5, and writing rest of them in this column. In prior solving, let's revisit again the concept. So this is your expression. In this case, it is an equation. Why? Because we have learned in previous chapters that whenever expression is having 2 sides, that is left hand side and right hand side, and equal sign is there, then it is an algebraic equation. But it consists of expressions on both sides, that is left hand side and right hand side. On right hand side, we have only one thing, that is constant. It is 5. Its value will not change. Therefore, it is a constant. And on left hand side, 7 is a constant here. And what is a coefficient? It is the numerical part most of the times. It can be variable as well, which we will study in later questions. So here we have variable x because its value can be changed. And operator is the sign. Here it is getting subtracted. Therefore, it is an operator. So now visiting the question, first expression is minus 4x plus 5. So we have 2 terms, this and this, that is minus 4x and 5. And we have to write factors representing each term. So in minus 4x, we have factor as minus 4 and x because they have individual identities. And in 5, we have 5 as a factor. That's A. B. Expression is minus 4x plus 5y. Again, it is like the same, but only addition of y is there in 5. So again, we have 2 terms, minus 4x and 5y. We don't have to write plus. And factors in minus 4x are minus 4 and x. Therefore, you write it with the help of comma. And in 5y, we have 5 and comma y as the factors. That is, these cannot be further broken up. Now see, 5y plus 3y squared. Again, we have 2 terms, namely 5y and 3y squared. So writing the same. And in this, we have 2 factors, 5 comma y. And here we have 3 factors, that is 3 comma y comma y. Because y is coming 2 times. That's your C. D. xy plus 2x squared y squared. Again, we have 2 terms, that is xy. They are getting added up. Therefore, second term is 2x squared y squared. And factors in this are x and y. Therefore, writing x comma y. And in this 2, x is coming 2 times, y is coming 2 times. So now you got the idea. E part. PQ plus Q. So PQ is one term and Q is another term. Here factors are P comma Q and Q alone here. That's E. F. 1.2 AB minus 2.4 B plus 3.6 A. It doesn't matter if it is decimal number, yet it is a constant because 1.2 will not change its value. Similarly, this and this. Therefore, first term is 1.2 AB, another is minus 2.4 B. You have to write minus when writing terms because ultimately they are getting added up. And third one is plus 3.6 A. Well, you don't have to write plus, it is understood. Here we have 3 factors, 1.2 comma A comma B. Here you have minus 2.4 comma B, and here 2 factors, that is 3.6 comma A. That's F. Likewise in G, we have 3 by 4. It is a fraction and we have 1 over 4. That is, they are getting added up plus, well, again it is a constant because 3 by 4 and 1 by 4 will not change their value. Therefore, we have 2 terms, that is 3 over 4x and 1 over 4. Therefore, writing the same here. And in this, we have 2 factors, that is 3 by 4 comma x, and here we have 1 over 4. Therefore, 1 over 4 is our factor. That's your G. You can remove this line. This is of the same question. Now last part, 0.1 p squared plus 0.2 q squared. Again, these are constants and we have 2 terms, namely 0.1 p squared and 0.2 q squared. And here we have 3 factors, namely 0.1 comma p comma p, because p is squared. And again here q is squared. Therefore, we have 3 factors, namely 0.2 comma q comma q. So in this way, we find our terms and factors. So factors when they are written together, they form terms, and when terms are added up, they form expressions. This is how expressions are formed. That's your second part. Third, identify the numerical coefficients of terms other than constants in the following expressions. In this question, we have to find numerical coefficients. We don't have to consider constants. So first, visit the concept again. So what is a term? That is individual expression which consists of variables and constants. So in this term, we have various other things. So these are individual factors. 5 is a factor, and we have x 4 times. So therefore, total 5 factors are there. And what are exponents? These are the powers. That is, x is raised to the power 4. That is 4 times. This you will study in subsequent chapters. Well, we have a numerical coefficient. Numerical means it has number, and it is a constant as well. Now variable, these are variable. That is, x can take any value based upon our conditions, or it is also called as literal coefficient. So basically they all can be termed as coefficients. It depends upon the question. And to be more specifically, we have two types of coefficients, that is numerical and variable or literal coefficient. Again here, if we have expression 5x plus 7, then constants are these. And here in this question, we have to neglect or omit constants. That is like this. It is constant, individual constant. It doesn't have any variable attached to it. And this doesn't have any variable attached to it. So we have to neglect this. The similar thing we will do here. And in this, we have three terms, 5x, 7, and under root 2. About under roots, we will study in later chapters. And here as well, this is numerical and this is variable. This is basic. Now let's start the question. Again, we will make 3 columns representing expression, terms, and coefficients, and we will write the questions in rows. So we have written the same. First one is 5 minus 3d square. What are the terms? Here we will only consider numerical coefficients. Therefore, we are not taking 5, although it is a term, but the question says we just have to take numerical coefficients of terms. Therefore, we are taking terms which contains variables as well. So minus 3d square. So we have one coefficient, that is numerical coefficient we have minus 3. Therefore, we are writing minus 3. That's first. Second, 1 plus t squared plus t cubed. Again, we will not take this as a term because it is a constant. We will take these 3. That is t squared, and t cubed. So here, what is coefficient? If nothing is written prior to any variable, it is understood it is getting multiplied with 1. It has 1. Here, nothing written, therefore 1 and 1. That's second. Third, x plus 2xy plus 3y. Again, we will consider all the 3. So we have 3 terms, x, 2xy, 3y, because we don't see any constant like plus 5, plus 6 or any other constant. Here, again, nothing written means 1. Here it is written 2. Therefore, 2 is numerical coefficient. Numerical coefficient. And here, 3. That is third. Fourth, 100m plus 1000n. So we have to write both because we have terms which contains both numerals as well as literals. So these are literals, although they are both coefficients. So 100m and 1000n, and numerical coefficients are 100 here, 1000 here. That's fourth. Fifth, here we will consider both again. So minus p square q square and 7pq. Now here nothing written means minus 1, and here we have 7 as numerical coefficient. Sixth, 1.2a plus 0.8b. Again, we will consider both 1.2a and 0.8b, and numerical coefficients of these both terms are 1.2 here and 0.8 here. Seventh, 3.14 r squared. So this is the only term, therefore writing it. The numerical coefficient of this r square, that is literal coefficient, is 3.14. Here, twice of L plus B. Well, it is a formula of perimeter of rectangle. So First of all, we'll have to open it because it is not solved. So 2L plus 2B, we get 2 terms. Numerical coefficient is 2, here again 2. So writing 2 and 2. Last one, 0.1y plus 0.01y squared. Again 2 terms, writing it 0.1y, 0.1y squared. Here we have numerical coefficient as 0.1 and here numerical coefficient as 0.01. So in this way, you differentiate between terms and coefficients, and that's a third. Question 4th. A. Identify terms which contain x and give the coefficient of x. And B. Identify terms which contain y squared and give the coefficient of y squared. In this question, we have to only consider those terms which contain x. And then after doing so, we have to give their coefficient, that is coefficient of x. So first of all, we will form a table containing 4 columns, 1, 2, 3, 4, writing headings as expression, terms with x and coefficient of x. And we will write all these expressions that are given in the question in this column, and now let's solve it. So again, we have to identify terms which contain only x. So here we will not consider this term, although it is a term, but it doesn't contain x. Therefore we will consider only this term. Therefore writing it y square x. And now coefficient of x means that whatever we have apart from x, that is attached to x in this term, that is y squared. Therefore we are writing y squared. That's first. And second, 13y squared minus 8yx. We will consider only this term. We will omit or will not consider this term because it doesn't contain x, that is variable x. Therefore writing minus 8yx. Again, you know very well why to take minus, because ultimately expression is nothing but addition of terms. So here coefficient of x, that is every other thing apart than x, that is minus 8y. So we write it here. Now third, x plus y plus 2. Only we have to consider terms with x. Therefore it is the only term, writing x, and nothing is written with it. That means coefficient of x is 1. Here 5 plus zx. So with x only, we have zx, writing it here. Everything apart than x is z, writing z as the coefficient of x. Now here we have 2 terms which have x. Therefore x and xy. For x and xy, here coefficient of x is 1 because nothing written with x. And here everything apart than x is y. Although 1 is there, we don't write it because it is 1y. Therefore y. Here this term only because it doesn't contain any x. So 12x y squared and everything other than x, because we have to find coefficient of x. So 12y squared. Last thing, 7 plus xy squared. So only this term. If writing xy squared and everything other than x is y squared, therefore y squared is the coefficient of x in this term. So in this way, A part is finished. B part. Identify terms which contain y squared and give the coefficient of y squared. Now, again, creating the same table, writing the same headings, and jotting down the questions. First part. So in this, we have to write terms with y squared. So here we have y squared, we will consider this term, that is minus xy squared, and coefficient of y squared, because we are asked to find coefficient of y squared, so every other thing except y squared. So we have minus x, so writing minus x. Second, 5y squared plus 7x. So y squared, we have to consider terms with y squared only, so 5y squared, we will write it, and every other thing then y squared is 5. So 5 is coefficient. Now here y squared, we don't have any y squared. We will not take this term. We have here and here, so we will take both the terms. That is minus 15x y squared and 7y squared. And here every other thing then y squared is minus 15x. Therefore, writing minus 15x. Here 7. Writing 7. So in this way, you find your terms and coefficients. That's b and that's 4th. Question 5th. Classify into monomials, binomials and trinomials. Monomial. A monomial is an algebraic expression containing only one term. So here we have only one term, therefore minus 2x raised to power 5 is the monomial. And what is a binomial? Having two terms. That is x square plus 5 is an example of binomial. Trinomial means 3 terms. So these are English terms. Mono means single, bi means 2, tri means 3. And for any other algebraic expression that contains more than 3, we can name it as polynomial. That is 4-term polynomial. 4 terms, 1 term, 2nd term, 3rd term, 4th term. And very important thing to note is that monomial, binomial, trinomial, they are termed as polynomial as well. So a polynomial is any algebraic expression that exists. So monomial is a polynomial, binomial is a polynomial, and trinomial is a polynomial. Keep this in mind. Now let's find. First one, clearly visible. We have two terms, namely 4y and minus 7z. Therefore, it is a binomial. So here we have a monomial consisting of only one term having two factors y and y. Therefore, it is a monomial. Here x plus y minus xy. 3 terms, 1, 2 and minus xy. 3 terms. Therefore, trinomial. We have single constant, that is 100. It is a monomial. So see, these all are polynomials. Now here, 5th, 1, 2, 3, trinomial. Here, 1 and minus 3t, another term, therefore binomial. Here, 4p square q minus 4pq square. Here it is a binomial. The only confusion that may appear is that we have two same variables, that is p and q. So therefore they must be monomial. But no, you have to consider powers with them. That is, here we have two factors of p, but here we have only one factor of p. So that makes a difference. Had it been like p squared q, then it would have been a monomial. But it is not the case here, therefore it is binomial. Here clearly monomial because we have 7, m and n as a factor of only single term, therefore monomial. Here we have 2 z's, here we have minus 3z plus a, therefore trinomial. That is 1 term, 2nd term, 3rd term. Here we have 2 terms, a square and b square, binomial. Here again very similar to this thing, but it is a binomial because here we have 2 factors of z and only 1 factor of c. Had it been like z square, then it would have been a monomial. The last one. Here it is again trinomial because 1 term, 2nd term, 3rd term. So x and x square are not same because here we have 2 x's, here we have only single x. Therefore it is a trinomial. So that's your 5th. 6th, state whether a given pair of terms is of like or unlike terms from 1 to 6. So what are like terms and what are unlike terms? So you have studied in this exercise in algebra consisting of variables and constants. We use letters to represent unknown quantities, and also they are called as variables. These letters are called variables, same thing. Terms that have the same letter or variable are like terms. Those that have different letters or variables are unlike terms. This is mathematical definition. How you could understand it in day-to-day life, let's consider examples. So here we have 2 examples. This is an orange and here we have orange juice. Are they alike? Well, no. They are not alike. Why? You cannot compare oranges with oranges juice because although they are of same species, but they are not of same form. That is, these oranges are processed. They are juice now. They are not like real oranges now. So therefore they are not alike. The definition was saying terms that have the same letter or variable are like terms. Again, another example. Are we alike? So we have here apples and apples, although their numbers are different. Here we have 6 apples, here we have 8 apples, but they are apples, they are alike. Yes, you are comparing apples with apples, not apples with apple juice. Therefore, those that have different letters of variables are unlike, like we have here. So with this analogy, let's visit the question. So first, 1 or 100. Yes, they are number. As we have here, numbers can be different, but they are numbers or constants. So therefore, they are like. It can be 1 apple or 100 apples, but they are like. Or it can be 1 donkey, 100 donkeys. 1 tiger, 100 tigers, but yet they are tigers. Therefore, like. Now here, minus 7x, 5 by 2x. Consider x as apples, monkeys, or elephants. Minus 7 apples, 5 by 2 apples. Yes, eventually they are apples. So therefore they are like. Now here, it is like minus 29 donkeys, minus 29 horses. So they are not like because x and y are not same letters. Therefore they are unlike. Now here, 14xy, 42yx. Well, the important thing to note while considering like terms and unlike terms, it doesn't matter if you write first horses or donkeys or horses. Eventually, you're comparing same thing. So therefore, they are like because xy can also be written as yx. Therefore, they are like. Now, m square p, mp square. Here, they are not like. They are unlike. Why? Because here, m square p will give you some other value and mp square will give you some other value. And at which condition they would have been like? If we had m square p and m square p, then they would have been like. But in this case, they are unlike. So while deciding like and unlike, always compare pairs of given variables. They must be same on both terms. Here, again, even though variables are same, x, z, xz, but their pairs are not same. That is, here x is not squared and z is not squared. Therefore, they are unlike. So this is all about like and unlike, and that's your 6th. 7th, identify like terms in the following. We have 2 parts, A and B. Again, we have the same kind of question as we have previously. First, let's see this example. So we have 3 x's here, we have 6 x's here. Well, are they alike? Yes, both have same variable x. Now, it may contradict your thinking. If we have 3x square and we have 6x only, then also we have same variable x. But always remember, this is the only difference here. 3x is not equal to 3x square because we are comparing x one time with x 2 times. So squared is not very similar to multiplication. This you will get with practice. So here, are they like? Yes, they are both cats. Here, are they like? Even though they appear to be friends, but they are not like because you cannot compare a gorilla with a tiger. Now let's visit the question. So in this, we have to find like terms. So the easiest way to do such type of question is this. First of all, let's consider this term. We will write it. So now we have to see in rest of them in order to make pair that we have to take 1x and 2y's. So 1x, no, here we have 2x, we cannot take it. So we have, no, here we don't have any y. 1x, 2y, well yes, we will write it, we will cut them so that we don't get puzzled because we have considered them. Again, we have 1x, 2y's, well, we cannot see any such. So one pair is formed, therefore writing it like this. Now we are here, that is 1y, 2 x's. We will write it and we can cut it. So we have to find 1y and 2 x's. 1y, 2 x's. Well, here we have, although the order is not same, that we have also discussed earlier, that order doesn't matter. But we have 1y and 2 x's. Therefore, we can cut it and we can write it here. So we have 1y, 2 x's, 1y, 2 x's. Another pair has been formed. Now we have to consider 2 x's and writing it here. Well, we have 2 x's here. We can write and cancel here. And again, we have here 2 x's. That is x squared. another we don't have. So third pair has been formed. Now we have to consider single y. So we have written here 7y. Do we have any single y? Well, yes, we have. So we can cut it and write it here. We have made fourth pair, and now we have this 1x. Writing it first of all, do we have single x somewhere? Yes, we have here. We can write it here, making our pair. Now we are left with only two things, that is 1y, 1x, and here we have 1x, 1y. So we have made 1, 2, 3, 4, 5, 6 pairs in total, and that completes our A part. In this way you don't get puzzled and your question is also solved. Similarly for the B part, first of all we will write this with single p and single q. We will write it here, comma. We will find single p and single q. Well, it is not. We have two p's and two q's. Well, here we will cancel it and we can write it here. First write it, then cancel it. Single pq, well, we don't have here. Single p and single, well, we have here 78 qp, and with this a pair has been formed. Now we will write 7p and we will cancel it, comma, finding only single p. Well, single p is here. We can write it, and we don't find any. Then we will write 8q and cancel it. 8q, single q. Well, here we have minus 100q, and rest we don't find any single q. Now another pair, 2p and 2q's. We will write it, 2p and 2q's. Well, we have here. We will cancel it and write it, and we don't find another. Now we have only single constant. Do we have single constant? Yes. We can write and cancel it, and now this makes a pair of like terms. Now we will consider two p's and we will write it here. Well, we have two p's here, the last, and this makes a pair having two p's, that is p squared. Now we have this one, two p's and single q. We can write it here and cancel, and then two p's and one q. Although it appears at first glance that they are not like, but when you count their powers they are, because we had two p's, so we had two p's and single q, and we write it, and that makes our pair. So in this way we find like terms, and this method makes our process easy. That's your B, and that's the last question, question number 7th.